Good morning, everybody. We're going to hustle today and try to get through the beginning of Chapter 9. And Chapter 9 is on sequences and series, and there are 5 sections in Chapter 9. Now, first thing that you need to understand about Chapter 9 is that we're going to be dealing with patterns only. And a pattern is simply a sequence of numbers. A sequence is a list of numbers in some sort of pattern, and a term is one of the numbers in that sequence. We notate that a couple different ways. I might say a sub 2, and that would be the second term in sequence A, or b sub 5 is the fifth term in sequence B. That's all there is to it. Now, there are two different types of patterns there's two different ways we can describe patterns. There's the recursive way and the direct way, and the truth is you learned these a number of years ago, and you learned them again last year in Algebra 1. The recursive formula is a simple question of what's next. So if I give you a pattern of 1, 3, 5, 7, 9, blank, and I ask what's next, you're just going to count by 2, and you're going to tell me what's next, which is easy, right? So 11 is next because you know that we're adding 2 each time. But what if I give you something, by the way, that's recursive, right? A recursive pattern requires the thing before it to learn the next item. But what if I asked you the 100th term? Now you could count out 100 terms, but nobody wants to do that. So we're going to use a direct formula there to figure out how to come up with a direct formula. Let's go ahead and take a look at that same formula again, but this time let's look for the a sub 100 or the 100th term. So a to the first is 1, a to the second is 3, a to the third is, I'm saying to the third, I make a mistake. A sub 3 is 5, a sub 4 is 7, and so on. So we're identifying the number of the term and what its value is. The second term is 3, the fourth term is 7, and so on. Well, here's what we're going to do. We're going to start looking for how these numbers are different. So 1 to 3, 3 to 5, 5 to 7, they're going up by 2, just like we've seen in the past. And what we're going to establish is that there is a pattern that would describe them. If I doubled this number, if I doubled this number, the n value, and I'd get 2. If I doubled this, I'd get 4. If I doubled this, I'd get 6. If I doubled this, I'd get 8. Notice it's always one more than what I want. So my pattern is simply going to be double the n value and take 1 away. So if I go to the 5th to test it, double the 5 is 10, 10 minus 1 is 9, and look how I get my 9. So all of a sudden I know what my pattern is. My direct formula is a sub n is 2n minus 1. Back in the day, you would have seen something like this. Oops, or this would have been minus. You would have seen a pattern that looked like this. We'd call this the slope, and we'd call this the y-intercept. Not really any different now. We're just using slightly different notation. So go ahead and figure out what a sub 100 is. Good, and we'll move on. All right, next up, go ahead and deal with a few things that you have to deal with in your work for today. The first type is finding the first 5 or 6 or 10 terms of a sequence. I've made up a basic sequence here with a direct formula, or what we might sometimes call an explicit formula. A sub n is n plus 3 divided by 2. And if I want to find the first 6 terms of the sequence, I'm just going to create sub values starting at 1 up through 6, because that's the cap of what we're doing. And here's how this works. A sub 1 is, so if my 1 goes here, I'm going to get 1 plus 3 divided by 2. Or if I have the second one, 2 plus 3 divided by 2. And you get the idea. Now, once you have them all written, you can simplify them. And just like that one, and I'll do the rest, you would simplify and get your whole series. Sometimes you'll notice with linear series as well, you can see the pattern develop. I know this is going up by a half each time, and I can see why it's going up by a half. So I can jump ahead a little bit, and I can skip the math, and I can simply list, a little sloppily, but I can list my first 6 terms in the sequence. Okay, So how do we write a recursive formula? We know how to use a recursive formula, but how do we write one? Well, let's go ahead and identify the two things we need to have. We need to have a starting value because all patterns start somewhere, and we need to know how it changes. So let's take a look at this recursive formula right here, 1, 5, 14, 30, and 55. The first thing that I'm going to identify is the starting value, and I'm going to do it like this. My pattern is A, and you can use any letter you want. I'm just using A again. The first term in this pattern is 1. That's going to be half of my recursive formula. So I want to make sure I say this. If this number were a 2 or a 3 or a 10, this would be a 2 or a 3 or a 10. Now, for how it changes, let's go ahead and identify a couple things. I'm going to grab a pencil instead of this big thick marker, and I'm going to try to identify how my values are changing. Not unlike how I would have done it in classes before this one. So 1, let's see, plus 4 is 5, 5 plus 9 is 14, 14 plus 16 is 30, and I can already see that there's some sort of pattern there with what look like perfect squares. Okay, what do I do with that? Well, let's find out. This a to the first, a to the or a sub 2, a sub 3, a sub 4, and a sub 5. I guess what I'm trying to figure out is what's a sub n. So that's what I'm actually trying to identify in this particular case. Sorry, I'm not trying to identify that. That would be a direct or explicit formula. So what I'm trying to do is, I guess, describe how this thing changes. And when I look at how these change, what I notice is there's a relationship between the one that I'm on and how it increases. The one that I'm on and how it increases. Notice how there's a relationship here. Now we might get a little bit lucky sometimes, but it's okay to be lucky. So let's go ahead and identify how this is changing. Here's what I might identify. If I could say that let's guess on the sixth one, a to the 6. I bet most of us would imagine that this is going to be a plus 36. And we could do that because we could identify the pattern, or because we could look at this 6 and know what we're going to increase by. So I might write a sub 6 is the 6 itself squared. That gives me the 36. And I'm going to add that to the 55, the one that was before it. Now, the one that was before it, I'm going to generically list it as a sub 5. So look what I've done. I've identified that I need the previous value to get the new value, and I've shown you how to come up with the next amount added on. Let's make this more generic. I see a 6, so let's make this a to the n and n to the second. And instead of a to the 5th, which was fine when we were dealing with a to the 6th, we want the one before it. So it's a to the n minus 1. So look what I have here. This and this as a combination is my recursive formula. So I'm telling you the pattern starts at 1, and I'm telling you the pattern is take the number of the term, square it, add it to the previous term, and you'll have your answer. The only thing that we have to add on oftentimes is we have to add something like n has to be greater than 1 because we need to make sure the pattern gets far enough along that we can actually do this. So that's how you write a recursive formula.